different team. There's some small frame analysis I want to do here. I decided, let me try to demonstrate how I can come up with this. So it's a 20 by 9 meter. Of course, that 20 has a subdivision of 5 meters. So after opening my new model here, I got first thing I need to do is, once I understand that frame has a column of 250 by 250 and a beam of 300 by 250. The longer span has 5 meter spacings and then 9 meter. Some areas has a block infill, so I just want to quickly run a quick model and check the column reinforcement and beam. So I go to my property materials, I come to add material, I go to steel concrete, so concrete. When I come down, I think first try compressive of 25. If the model does the design, that would be good. If not, I come to 37 because this model might seem to start more design compressive of 37 to give you reinforcement checks. But basically this plate, but let me also try that. Though most columns are supposed to have compressive of that, but this is a little bit complicated building. So you have that, you apply. Is there another material? No, this is the only beam, and then there's the section. First close that, then I go to my sections. I add the section. Here I need a rectangular solid section, and I do user, and I call this RC. And having done that, this is 0.3. 0.3. I apply that, then I add the beam, which is now like a beam. So I have that 18.0 by 0.25. That's the breadth. Now here remember it's got to do the center top. So when I measure from the top of the beam downwards, so I put my center top, and then I say okay. You can see now the reference point is here. I apply, and that is what I've done. I close, and I look at the whole thing, they're all here. Then having done this, I'm now going to go to loader. From loads, I created a loader point, I apply. This is now where the load is created. So what I do now, using the extrude command, I will extrude my column. Here is all given here materials and the columns, and then the tip will be going up, so 0.5 and it's going to after the ring beam is 3 meters. I put my 6 in. If you multiply that is the column, and the view, that is the view. I can subdivide this into, I can see what I subdivide this into. So I come to division here, and then I want to do more, I apply. So that is what I do. Now this column, I told you now I can offset. This is my column building. I can offset this column. They call it translating. So I translate this column in the y direction by 9 meters. And I make sure all the knots and intersections and elements are copied. I apply is there. Then I need to offset this column again in the x direction, which is 5 meters, and there are 4 of them, giving me by 20 meters. So these are the column of first you can do. Then from having done that, I told you, then I can connect. How you have to connect the beams. So there are 2 lines of beam. There's one at the ring at the window level, and door level, then one at the roof level. So I come and create element. I am creating now the beam. I create the first one. I create the beams at the roof level. This section has a compound. This is an open area. This is an open area, and this is the classroom enclosed with the wall. So Then I need the second beam. That's about 2 meters. That is it. So at around 2 meters, you have that, and then around 3 meters, you have that, and then I also connect this, I connect this, and then also try to connect this beam. So when you view, you are done with that. But I want also to break them into just subdivide it. That's when you just subdivide this into 10. For smoothing of your bending moment and zero for so here I put 10. Now where we have wall here, I'm going to create what they call spring constant, because it's not pure, this is purely suspended, while this is not suspended, this one is suspended, this one has wall down, this one has wall down, this area has wall down, and that one has wall down. So I'll do this, I highlight all these knots here, I highlight them, I can do this knot, and also highlight this knot. So when you have 3D, that is the knot, the rest are gone, and then the upper one also will be highlighted. This one, because there are going to be, there's a beam infill here, so you are able now to do what they call boundary spring constant. I will fix it for one, but I can give it value. I need to research and get it running. So that defines my simulation that they are bearing on something, they are bearing on the wall. So that is what we need to do. Then now, having done all that, I make sure I also give I am going to make a boundary connection to simulate the foundation at this point, but I would have connected down that the middle at this point, had the stop column position. I come to boundary and make sure I do that, fix it. We have that fixed. So I can now save this. I can save this model I can do it here. Okay, so I could say now I'm done with this. So what more do we do? I can done this model is ready enough. The model is done. Now I need to apply the loads. When you want to apply load before that, okay, load. Then I go to my loads. I go to my static. Then I do self weight. I told you if the load case name self weight normally is the date load indicated as D to reflect the member size you're given. Then like we have a date load that we normally do, we add on this. That is now the date load, another component, and then I need the live load. The live load always given down here, and then for this building, I don't expect to win this, so I'm not going to include win magnet before. Even if could do that, but I think I will do that, and then I close. And then here, the self-weight load case, don't forget number to be this. Then under this self-weight factor, it is Z and negative 1. Make sure you add it. If you don't, it means the other load will be affecting your building. Self-weight will not be taken. So I can quickly move around a quick self-weight load and see how it behaves. So if that is this for self-weight without another loading, I look at my reaction to self-weight, region and value. Now my problem is because I had indicated the spring here, that is why it's appearing. You get it? That's how it's appearing. So if I first go back and delete it, will I get the same? Will I get the same value? That is something worth trying to see. So I made them it is 18. Look, more or less 18. So here I come to my spring and then I delete. Having deleted, I go back and run a design. Now we want to see whether we have a similar behavior, reaction, self-weight. This is 2 you see. So when you connect it up, there's a way the thing takes. So that means over the walls here, some loads are taken by the wall. This is something very good demonstration. There's amount of column, amount of load going to column will be reduced. This is what you need to do. And so that is what I think we can do. But now that means for now, for worst case, let me leave it at this, and then I can do the loading. I think it's about time up. Let me stop this, then I do the loading analysis later. This is a quick demonstration of how you can quickly look at your model up to the stage you can start application of it. Thank you.